Cool.
All right. So we'll get running here. For those of you who have seen this presentation before, sorry to use the same theme as last time, but the slides are like kind of different, but it's the same theme. So if you've seen this presentation before, it will look really familiar. For those of you who've never met me before, my name is Brennan. I'm a site reliability engineer by trade. I'm going to be talking today about what site reliability engineering is, what a site reliability engineer does for like day-to-day work, kind of like what is it like to be an SRE, what kind of problems do we solve, what do we actually do, what is like the definition, and then I asked in the Discord for a couple topics that people wanted to go over because I didn't feel like I had enough to talk about. And so someone asked me to talk about operating infrastructure at scale. And someone else asked about specific AWS services, so I'm going to be going over both those things as well. And I have some time built in for rambling, because that's usually what I end up doing anyways, and then taking some questions from y'all. So I kind of like to start off presentations with a why you should listen to me section. I feel like this is not gone over very often by like a professor or something. They don't really tell you why they are qualified or anything like that. They just expect you to listen to them because they're standing in the front of the room. So just a little bit about myself. I am a site reliability engineer. Like I said, I've been at SRE for 5 years. This is my 5th year being a site reliability engineer. I'm actually moving into a senior role. I just accepted a new position. So I'm moving into a senior site reliability engineering role. Yeah. I have experience with GCP, Azure, but primarily AWS. Every single company I've ever worked for has been an AWS shop. My experience with GCP and Azure is typically making some niche product work for some random company whatever company I'm working for either acquired or is selling a product to. So I have some experience in GCP and Azure, but AWS primarily. If you've used GCP or Azure and not AWS, they are just AWS, but blue and green respectively. AWS is just the yellow one. I have experience operating infrastructure at DraftKings. We like to joke about it being at Super Bowl scale. What that really means is right around the neighborhood of north of 10,000 EC2 instances running simultaneously in all production environments. So operating infrastructure from the scale of north of 10,000 EC2 instances, actually like on the Super Bowl, my first year working at DraftKings, we had to work with our AWS technical account manager to actually physically move hardware from US West to US East because we ran out of hardware in US East to buy from Amazon, right? So like pretty large scale, down to really small companies. My smallest company I ever worked for, the whole office was probably half the size of this room. My desk was here, and the CEO's desk was that side of the table. I didn't have enough room for a monitor or anything, so my laptop just opened directly into the back of his desktop monitor. So I've worked at really small companies, I've worked at some big companies. Some non-SRE things about me. I went here for some amount of time. I finished school in 2020. I did not graduate. I am a college dropout, so you can ask me about that if you want to drop out of college. Don't do that. But if you want to, I can tell you why it's a bad idea. And then I was also a college tour guide in RA for a while. Maybe you're too young, maybe I'm too old for you to remember me in those capacities. I was an RA in Fox 2019 and 2020 academic years. So the COVID year, I was an RA on the 8th floor, so if you remember me from that, I'm so sorry, because we lived together during COVID. For a while, I was a full stack developer, and that really sucked. So if you have questions about being a full stack developer, I can tell you why it's like a terrible thing to do. Anyways, what is SRE? How is it not DevOps? Why should I care what it is? Why should we do it? What makes an SRE? And how do we do SRE? Right? So I just kind of Googled like basically what is SRE. The first definition from Google, right here at the top right, is when you treat operations as if it's a software problem. And that's, I think, the thing that resonates with me the most. Site reliability engineers are software engineers, right? Like, I spend most of my day writing code, right? I am still a software engineer. I just solve operational problems, right? It's an approach to IT operations, it's the credentials, or the crossroads of traditional IT and software development, right? So why are there so many definitions of this? Why are they so different, right? I mean, the Google definition seems pretty cut and dry, but I would say the Splunk definition is like pretty vague, right? So why should we care what SRE is, right? Well, SREs limit the impact of errors on customers. SREs are, and it's a slide about this later, but I'll touch on it now. SREs are customer-obsessed people, right? We focus on the customer at the end of the day. The customer is the most important thing that SRE works for, right? That means when you have a program with SREs, that means that there is less downtime, which means that the business that you work for is capable of generating more revenue, right? People can connect to the app more often, and therefore can spend money easier, right? That is more revenue for your company. Or they can view the ads inside your app, or whatever the hell it is that you do, right? They can spend money because you are reliable. Organizations with SREs are better collaborators inside the organizations, right? SREs co-own production with the DevOps teams and with developers, right? So we kind of are the glue between those two silos of like the people who might, if you have an on-prem server, like the people who like physically build hardware, or the people who like operate your networking hardware or whatever, and the developers, SRE are the middlemen. SREs are owners of everything, right? When we build something, we own it. When we, help developers build something, we own it, right? SREs own production. Additionally, SREs are highly focused on observability, right? So adding monitoring, making things observable and telemetrized is some of the most important work that SREs do. And it's something that I feel like not a lot of SREs necessarily focus as much energy on as they probably could, but it really does save you in the future from having larger problems. Okay, so why should you care, right? The first one is that SREs are the highest paid category of software engineers that are not quants. So you can make the most money in this field of any other field other than going into stock trading. So that sounds awesome because I do way less math than those people. So that's pretty cool. It's fast-paced, important work. It's not just random projects. We're not writing unit tests all day. Right? The work that we do in SRE is interesting and cool and helpful to actual people. Operations problems are unique and unsolved. Right? When we deploy an application, no one has ever in the world deployed that application before. Right? We are solving a problem for the very first time. So we can't just Google our way through the problem. We can't just ChatGPT our way through the problem. Right? It is something that is truly unique that no one has ever done before. And so things that are just regurgitators of information can't solve those problems for us. So it's actually a pretty cool thing to be able to do to solve challenges that literally no one has ever worked on. Right? And you do have a real impact on customer experience, sometimes positively, hopefully always positively, definitely though sometimes negatively. You will take down production at one point. At my last gig, we used to joke that you couldn't be promoted until you take down prod. It was just kind of a thing that everyone had to do. And you're not just creating like useless internal tooling, right? Like SREs get to be Superman, right? We wake up in the middle of the night when we get paged and we fix real production incidents that real customers are facing. So what makes site reliability engineers, right? Well, we are owners, like I talked about earlier. SREs own production, right? We own the things that we put into the world, and we operate those things with our developers and with our DevOps teams and with our IT teams, right? But ultimately, SRE are the owners of those things. We are the people getting paged. We are the people who are asked to fix them. We are the people responsible for putting them there, right? SRE are the owners. We value customers above all. We are customer obsessed, right? We implement the DevOps philosophy. So if you imagine like DevOps as like a class, SRE inherits DevOps, right? So we implement the DevOps class, but we don't actually do DevOps work, right? And we create the tools, not just use them. That is the major difference between site reliability engineers and DevOps, right? Like, who has heard of Docker before? Raise your hand if you've heard of Docker, right? So Docker was built by site reliability engineers and is used by DevOps people, right? That's the easy way to kind of think about that. So thinking like an SRE, we have to think about what is the DevOps philosophy. How many people have heard of the DevOps philosophy before, these 5 things? Yeah, so a couple. So the 5 major points of DevOps are we reduce organizational silos, right? We reduce things that are, and knock down kind of barriers between teams. There should not be one team that is working completely in secret from all the other teams on our application, and then they just dump it on their doorstep when it's time to go to prod. That is not how to make a successful application, right? DevOps prepares that failure is normal and inevitable. Applications will fail. Servers will go down. Networks will die. Hardware will die. We need to be ready for those things to have happened. We implement change gradually, not just right away, right? It's not the right way to change things to just push to prod on a Friday and say, okay, job done, and walk home, right? That is going to be a bad customer experience, right? DevOps people use tooling and automation, and DevOps measures everything, right? We never know what will be useful later when we're solving an incident. So we just measure everything, right? Because who knows, it might be useful later. And if it's never useful, we can always just throw it away when it's not useful. But SREs are not DevOps, right? Well, so how do we implement these things without being DevOps, right? We own productions with our developers. There are no developers and operators. SREs are glue here and work as one to deliver that, right? So SREs are developers and we are operators, right? We accept failure is normal and live blamelessly, right? If someone is able to, with one click of a button, turn off all of production, that is not their fault when they accidentally click that button. That is a process failure, right? There should simply not be an off button to kill a Fortune 500 company, right? That's a process failure, not an engineering failure. We make gradual changes by canarying things and testing things, often in a pre-prod or prod-like environment before moving to production. Although SREs are aware that sometimes we just have to test and prod, right? Some of the things we make, especially at a company where we're operating 10,000 EC2 instances, you don't know if it's going to work if you just test it in like 5 instances, right? The only way to test it is to go live in prod. And so we need to, in order to test gradually, be ready to roll back and be prepared to deal with the failure from that, right? We leverage and create tooling, not just leverage tooling that already exists, we also create our tooling. And the main reason we create tools is to eliminate toil. And we're highly observable. We measure failures, successes, and we measure all of our overhead and toil, right? So what is toil? It's kind of a key word that you'll hear SREs use. Let's first start with like overhead. Overhead are the parts of your job where you're not doing your job, right? That is going to meetings, that is doing TPS reports, expense reports, Slack messages, right? That is overhead. Those are things that are unavoidable and unautomatable, right? Toil is manual, repetitive, automatable, and devoid of long-term value jobs. So, like, let's think of an example of like overhead versus toil, right? Like overhead, like I said, would be like stand up every single day, right? You're gonna have a stand-up meeting, it's gonna take 30 minutes, it takes way too long every single day because people wanna talk about the weather at the start of the meeting, and it's totally pointless, and it can't work, and that's okay, that's overhead, right? That's just built in when your team calculates like how much work you can do in a week. If your team is not factoring in all the hours that each engineer spends in weeks every day, then you're not tracking your overhead, right? Toil would be something like, hey, once a week, someone has to go and manually restart a server, right? On Mondays at 5 p.m., some engineer takes a turn restarting a server. Or, another great example, on Tuesdays and Thursdays at 11 a.m., we manually apply all of our AWS IAM changes, right? All the devs write PRs for a week, and we manually apply all the IAM changes every Tuesday and Thursday at 11. That was a real thing that a company I worked for did, right? That is toil. That is engineering time that someone is doing, and they're writing the same 2 Git commands and the same in the CI pipeline every week to do effectively nothing. Like, why can't we just automate that away, right? So SREs we write tools and spend a lot of time just getting rid of this crap, right? There's no reason to spend our days working on toil. So kind of diving into some things SREs talk about, you might hear from folks are SLIs, SLOs, and SLAs. An SLI is a service level indicator. So this would be something like the status of the system or how we measure an error, right? So for example, for each HTTP server, we might measure 200s and 500s, right? That would be an SLI. If we see like a percentage of 500s versus 200s and it's like slipped below 95%, that might be something we alert on, right? Because the server is going down, or it's unavailable, or there's an issue, right? SLOs are typically a representation of how available we are going to be. It's our objective of availability, right? Typically measured in a number of nines. So if you hear someone say 5 nines of availability, that's 99.999, right? That's 5 nines of availability. Typically, something is measured in nines when we talk about SLOs. Some things are not measured in nines, and that's okay. And then SLA is the last part of this, and that is like an agreement you would make with the customer to basically give them money if for some other credit or change some contract objective or some business objective with a company if you don't meet your SLO, right? So that's to say, hey, if we are not 99.99% available, for each hour that we exceed our error budget by, right, that we will pay you X number of dollars back on our contract. We won't charge you for those, right? So I used a word there too of error budget. Has anyone ever heard that before? So error budget typically, like if you think about like, okay, let's take every second in a month, right? Let's just say, or let's say like an hour is our timeline, right? And let's say we want to be available 30% of the time for an hour, right? An hour has what, 3,600 seconds, right? So if we take 3,600 seconds and we divide that by 2, we get 1,800 seconds, right? So that means in every hour, if we want to be 50% available, then our error budget says that we can be down for 1,800 seconds every hour, right? Well, now if we are down for 2,000 seconds in 1 hour, that means that our budget has shrunk, right? The next hour, we need to make up our budget deficit. So we need to be available for actually an additional 4,000 or 400 seconds in the next hour to make up for the 400 seconds that we were not available for in the last hour. So instead of being available, if we were down for 2,000 seconds in 1 hour, we need to be available for 2,000 seconds in the next hour, right? To make up for the 400 second budget deficit. So like what is it like to be an S3? What do we do every day, right? Or what do I do every day? On-call is a large part of what S3s do. If you are interviewing for an S3 position, they will ask you if you've ever done an on-call rotation before. If you have ever been an RA or anything like that in college, you could say yes, you've done on-call before. On-call and incident command makes up a large percentage of like the stuff that you fear in S3. Like the things that are not the most fun part of your job, right? Getting woken up at 2 in the morning sometimes, going downstairs and trying to solve a problem can be kind of stressful. Trying to go to dinner with your girlfriend and having your MacBook and a backpack in the car and getting paged and having to leave dinner can be kind of stressful, right? But that's part of the on-call life. You just kind of come to learn and embrace those things. And also on-call at every company is different. At DraftKings, it was a 24/7 on-call once a week, every so many weeks. There are 6 engineers in my team. We were on call for a week. That means that there's every 6 weeks, you were on call 1 week. From Monday or Tuesday at noon to the next Tuesday at noon. DraftKings, of course, the on-call schedule is built around the NFL game schedule. There's no NFL games on Tuesdays, and there were some last night, so you would get off on-call when there's like a gap in NFL games. Aqua, where I was most recently before my new position, did a follow the sun model. The company was dual headquartered in America and in Israel. So the engineers in Israel worked our night shift and we worked their night shift. So I was only on call like noon to midnight, and they were on call 7 a.m. local to 7 p.m. local for their time, right? So every on-call structure is different, but they all kind of share the same incident command structure. You have an incident commander. The first person to show up to an incident is the incident commander until a dedicated incident commander comes and you relieve yourself of that duty and give that duty to the incident commander. It's a great time to step up and show leadership as an S3, especially if you're someone who wants to climb the corporate ladder and get promoted. Writing code, a lot of my days spent writing code, application, software, things that either make devs' lives easier, things that make customer lives better. automate ways to deploy things, that's where code. Stand-up, sprints, we do Scrum stuff, write Jira tickets, the usual coding stuff that you will do if you've ever done an internship or co-op. You will do these sorts of things. We do them too. Meetings, there are lots of meetings. There's stand-up every day, there's sprint retro, there are just fun hangout meetings with coworkers, lots and lots of meetings. There's also meetings to onboard new services and bring them into production. There are meetings with coworkers to discuss how to kill old services that can take months to deprecate, turn off, right? Terraform. Are you guys working in Terraform for your app this semester? Or CloudFormation at all? CloudFormation. Terraform is very similar to CloudFormation. It's a HashiCorp product. It's much more commonly used than Terraform. So you'll see more experience with CloudFormation. Excuse me. You'll see much more use of Terraform as opposed to CloudFormation. Yeah, do operational stuff that devs can't do. Sometimes there are tasks that developers just can't do, and you are not charging, but you're at 50%, so it'll be fine. There are some things that devs just can't do that we have access to, right? Sometimes we don't give the keys to production to our developing team because we don't trust them to not screw it up pretty often, right? So in order to do some things, devs sometimes just write a ticket and send it to S3 and I can't do this. Okay, we have to, right? We deal with scaling and the fallout of scaling, and if things don't scale correctly. We write tech plans. So tech plans are basically how do we go from where we are now to where we want to be? We have an application. The tech plan for an application would be we write a document for that application where we write out all the resources we think it will need. We write out all the steps it will take to build it. We write out all the infrastructure it will create, and then we can execute on that plan. As things change, we can look back at the tech plan and be okay, we need to update this. And that way, when we're done with making what we've made, it's documented, right? Other people can see how it was made. We reduce tech debt, right? A lot of the work that S3s do is spent reducing technical debt. The way companies work these days, if you work at a new company, they started as a startup with unlimited money, and they spent unlimited money, right? They literally built things in the fastest way possible, which is also always going to be the most expensive way possible, and also the worst way, right? Building something quickly is not building something good frequently. And so that leaves behind what we call tech debt, which is crap you just got to deal with in infrastructure now, right? There's sometimes there's a massive monolithic service you just have to work around and deal with. Other times it is some process that exists that's needlessly repetitive and stupid, right? Whatever it is that you have to deal with, that's tech debt. Whenever we create anything, a good way of thinking about it is I am making tech debt right now. Everything I create will be technical debt in the future. So how can I minimize effectively the future payments on the technical debt? How can I document things now? How can I prevent later stress and sadness when I have to come back and revisit this thing, right? We've all tried to read code we wrote from a long time ago and been ultra sad when we try to debug it and figure out what was happening, right? Even sometimes the next day you just can't remember what you were thinking, right? That's tech debt, right? So we want to prevent that from happening. We deal with other infrastructure provisioning tools, deal with CI/CD pipelines. S3, there's a lot of things that you end up doing, right? You end up touching a lot of different services in S3. All right, customer obsession, like I said earlier. We, as S3s, are customer obsessed, right? The focus of our work is positive customer experiences, right? The developers' customers are the people who use our application, right? When I was at DraftKings, the developers' customers are daily fantasy players, right? Or sports bettors, right? At Aqua, the customer, it was a SaaS company, right? A business-to-business company. So our customers were engineers at some other company, right? For the developers. SRE's customers, yes, are sometimes those people, but more often than not, scalability engineering customers are our developers. We serve our developer teams so that our developer teams can serve their customers, right? Customers always come first. We want to make things easier and better for our developers. We want to make workflows that work for our devs. We want to eliminate toil, right? We want to eliminate developers coming to us and with requests that only SREs can action. We want to give developers self-service tools so they can do those things on their own. We want to make it challenging to do the wrong thing compared to the right thing, right? So if we want developers to do stuff in a certain way, we should make that easy and make everything else hard. It's like child-proofing something, right? And like that's not meant as like a disrespectful thing, but like software developers are naturally curious people. Like we all know that. We are going to try to break things and do things the way we want to. Like very often, developers, and myself included, get tunnel visioned on, I figured out a way to solve this problem, and instead of thinking of another way or thinking of what's wrong with my solution, I am going to do everything in my power to solve it this way, right now, and just tunnel vision into that. And then later, when you step back, you're like, oh, that was kind of a dumb way to do that, right? And maybe we have a solution later. But we want to make that more challenging for developers, so that if they don't know what the right pathway is and they go looking, the right path is easy compared to the hard path, which is the wrong. Excuse me. Right path is easy compared to the wrong path, which is harder, right? We want to protect customers from themselves. We don't want customers to break things in ways that they cannot on their own fix, right? We don't want to get paged. And when they do things the hard way, sometimes in the wrong way, sometimes that means we do have to still support them, right? One company I worked for, the role of site reliability engineers was to partially maintain some custom Terraform modules. So you could inherit a module called like simple service, right? Which would give you like an EC2 instance and like an RDS database and like some S2S2s and SNS topics to like talk to things on, and it would give you like a DNS record, and it would put you in like a certain VPC behind the WAF and everything. And like if you wanted to build like just a simple normal web service that needs all those things, that is a great starting point for you. Please use that Terraform application. We would have teams come to us that did not use our Terraform module, right? And so we would say like, hey, since you didn't use our Terraform module, like as long as it's tagged correctly, the infrastructure you created is tagged in AWS correctly, like we're not going to destroy it. But if you have problems deploying it, we can't help you, right? Because you decided to roll your own thing, right? So that's what I'm talking about. Like sometimes we have to support our custom stuff. Typically that's like, if they have a problem with the custom stuff, we're not going to help them. But if it's a problem with our stuff that the custom stuff interacts with, then we have to help them. So operating at scale, what is that like, right? Well, what do services that operate at scale need to do or be? They need to be reliable, right? We don't want downtime when we operate at scale. They need to be easy to fix and work on, right? In a company where we are operating at massive scale, like at DraftKings, for example, when I was there, they had 250 microservices in production, right? That's 250 different services. I knew maybe how 3 of them worked total in the whole company, right? Knowing how the service works should not like inhibit your ability to fix a problem with infrastructure for that service, right? They need to be easy to deploy and create. So when we operate things at scale, we want to make things that are easy to deploy and easy to build, and also easy to destroy later. We want to make it easy to tear them down. They need to be process defined and constrained. What does that mean, right? A service needs to do exactly what it says it does on the outside of the box, nothing more, nothing less, right? When we operate things at scale, we want our services to be tight, neat piles of things that follow like the Unix philosophy, right? Which is like all software communicates in plain text. Of course, it communicates in like JSON now, but like whatever, sure, right? Communicates in text with each other. If you give it like a bad input, it just won't do anything, right? Or maybe it'll spit out an error. Like we want our services to follow that model, right? We want them to say, be very well defined. When things come in, I will do this. With correct data, I will do this. With incorrect data, and I will produce this output if there's a success. I will produce this output if there is a failure, right? That is required to operate at scale. Our services need to be able to be monitored or just to be monitored outright, right? So if our services can't be monitored at scale, we are going to have a really bad time in general in the world, right? If we put a service out in production and we can't track if things are going good or not, then how do we know if there's a customer problem, right? the amount of things, especially for like developers, will just accept in their workflow as just a thing they have to do. Like, oh yeah, every time we run the CI pipeline, it fails, so we have to kill the job and restart it, right? What? Like, no, you should not have to do that, right? But they'll never tell you. That'll never be a ticket. They figured out the problem, like the solution to that problem. They don't know what the problem is, but they figured out what the solution is like 3 months ago. And they'll just like casually bring it up sometime when you're like watching them over their shoulder and you're like, how are you deploying this? And they're like, oh, here, I'll show you. And they like kill the CI job and restart it. And you go, why'd you do that? Right? Oh, I don't know, we just always have to do it. My manager told me to do it that way. What? Like, no one told us? Right? So if we don't monitor things, how do we know they're broken? Because people won't tell us, right? We need to, like I said earlier, monitor everything. We need to capture all the data, because we don't know what will be important later. And services at scale, when possible, need to be able to fix themselves, right? I don't want to get paged for a service that the solution to it is to turn the computer off and on again, right? That is not a page I ever want to receive. Because it'll take me 30 seconds to action, but it will happen at 2 in the morning when I'm asleep. It'll take me 15 minutes to get to my computer, because that's the maximum time of our SLO that I'm allowed to get to my computer in is 15 minutes. I will take all of my time just to click 2 buttons in AWS and then go to bed, right? Like, that's stupid, right? And so the services should be able to self-heal. So how do we achieve these goals? I'm so sorry, the text on this is very small. We make robust services for reliability. We make robust services and we scale them. We need to make services that are well-defined. How many users does this backend support at once? How many concurrent connections? How many concurrent requests? How many concurrent requests can our infrastructure support? Okay, now that we know those things, we can scale based on those variables, right? We need to, like, our fault tolerance is up to the service writers, right? So if the developers are writing our service, we need to be working with the developers to basically say, hey, instead of like the code crashing, you should just generate a 500 here, right? Because the server can't crash, but it should output a 500 to tell the customer, like, happened, right? Then it would be easy to fix. Like, can we just restart the pod or the container or the instance? The amount of times the solution to fixing something is to scale horizontally and then descale horizontally again, like create a bunch of new instances, like double the size of your like load balancer or whatever. And then if you remove instances from the load balancers are almost always configured to remove the oldest instances first. So you just double the size of your load balancer, make sure the new instances are taking traffic and like working and there's not like a correcting the errors from them. And then you just decrease the load balancer by half and all your bad instances are gone, right? That's called rotating the load balancer. Yeah, can we just do that? Can we just like delete crap, or can we just like restart it, right? Can we replace instead of delete? Services need to be created as code, right? When we build infrastructure, nothing should be hand built. We shouldn't be logging into the AWS, like if every second you spend logged into the AWS console is a waste of time, right? Like we should be able to do everything from our IAC provider. And obviously that's not always true. Right, like it's not like we are going to have to log into the AWS console, but we should be trying our best to just do everything as code. We should not be hand building anything. We should not be modifying anything by hand. And if we are modifying something by hand, it needs to be something that IAC doesn't care about. So like in my example earlier about scaling the load balancer or then descaling the load balancer, like your infrastructure as code does not care about the size of the load balancer. It sets an upper bound and a lower bound and just lets it run in that bound. So if we manually overwrite that and unoverwrite it ourselves, then our IAC platform is not going to care. But like IAC, the infrastructure as code again, right? So Terraform, CloudFormation, whatever other weird thing that you might be using for IAC, like some people do like infrastructure as code with like Ansible and like Chef. Don't do that. Right? Don't build any of that stuff with like Chef. We should have no monoliths. We need to have microservices that work on the Unix philosophy, right? We need to know what metrics matter to collect, right? Like for an HTTP server, we probably want to collect 200 and 500s, right? Like that's probably all we care about, realistically, right? We might care about like the network utilization and the bandwidth utilization and maybe like the CPU usage and how warm the instances are getting, but like right? Is the server working? It's just a question of how many 500s is it generating. Because if it's not generating 500s, then it's probably working. And as long as there are 200s coming out of it, then it's probably working because it's taking requests, right? And like self-healing. If the container can just be restarted, can the load balancer just kill the container if it stops working? Like, can we just have like if we make an HTTP server, right? Imagine we have a service that like you can, like an API, for example, where you can just like send some random GET request and get a JSON document back, right, to your service. Can that server also have an endpoint called health, where you just ask like you send a GET request to the health endpoint, and if the server is up and running and things are responding well according to its own internal metrics, it sends a 200. And if it's not, it sends a 500, right? Because then we can just ask that endpoint every like second or whatever if it's healthy. And if it says it's not healthy for a certain amount of time, then we can just tell our load balancer to scale a new container, take all the traffic from the old container, direct it to the new container, and then kill the container, right? Like we can just make things self-heal, right? So talking about things that we do touch in AWS and some of the systems that I've probably worked with the most. We own production. I like to joke that it is easier for me to name the AWS services that I haven't used than the ones that I have, because I've used almost all of them. DraftKings and Aqua were both AWS shops. I like to joke that if AWS offered a solution to a problem, we bought it, right? We owned every AWS thing. The amount of money that companies spend on AWS, like as an SRE, you get like admin creds, like the AWS console, which means you get to see like the billing panel. Like right when you open the AWS console, it shows like the billing panel on the main page. Holy crap! Like holy crap! Like in 1 month, we're spending more than like my entire team, including my salary, like including my manager's salary, just on AWS infrastructure, right? Just in 1 month, we're spending more than like all of our annual salaries combined, right? So like insane. Absolutely crazy how much money people spend on AWS, right? So we use everything. SREs you will have to interact with every AWS service. Doesn't mean you need to know how to use AWS services. You need to be able to know how to read the documentation, right? If you can read AWS documentation, you can use they are designed. AWS services are designed for non-SREs, like just developers, to be able to like fumble their way through creating like the most expensive thing. Right? Like that is how AWS guides are written. So like, okay, sure, like we can learn from that, right? And like if you know a couple tricks, you know how to reduce the costs of things, right? Some of our resources are outside of AWS, right? At DraftKings, DraftKings obviously a regulated gaming company in the US. That means that there are no, if you might know about the US, there are not very many federal regulations. Gaming is left to the states to regulate. So the feds don't do any of that regulation, the states all do it. There are 50 states, which means there are 50 different sets of regulators, and they all do things differently. Some regulators want like an API endpoint for you to demonstrate certain requirements to them. Others want an email to demonstrate those things, right? One of our regulators in specific, like when we were moving into a certain state, in order to test, like part of the interstate commerce laws that apply to regular gaming are that the cash registers for what's considered a casino, so a sports betting product, right? The cash registers for that have to be physically located inside state boundaries. And not only do they have to be physically located inside the specific state's boundary, which is almost always true, but in some states it has to be physically located inside a building with an address that hosts a gaming license, right? Like already. So like you're not gonna find a building that's like a server warehouse that already has a gaming license. Like those places, like that doesn't exist. What they're talking about is like the broom closet in a casino, right? So we were building like server rooms, like we would partner with like, you know, like Philadelphia or whatever, like BetMGM would partner with like Hollywood Casino or whatever. That means that their server infrastructure is physically located inside Hollywood Casino. And what the state regulators would do is they would be like, okay, like we need to make sure that this server is the cash register. So they would open the demo version of the app they had, they would place a bet, and then unplug all the wires from the back of the server, and then they place the bet again. And if it didn't work, that meant that it was working correctly, right? Like that is like the tier sometimes of technical knowledge that you're working with, right? And so like some things are not are on-prem, right? Like these servers are on-prem instances. They're not always in AWS, right? Some things are companies that your giant, massive corporation has acquired, and they use GCP. And so now you are asked to help them migrate to AWS from GCP, or work on that GCP infrastructure, because migrating it sounds expensive and hard, right? So now you're asked to maintain that, right? So not everything you'll touch will be inside AWS, and also like, if you go to like an Azure shop or a GCP shop, like if you work for example, Walmart does not use AWS because Amazon is a competitor to Walmart. Amazon.com is a competitor to Walmart.com. And even though like the server business of Amazon is not related or tied to the web store interface of Amazon, Walmart still won't use it because it's like giving a competitor money, right? So they use Azure instead. So yeah, some things that like we probably touch a lot. The big ones, EC2, but that's like going away slowly but surely as companies realize how awesome Kubernetes is rather. They're ditching all of their EC2 infrastructure to buy cheaper Kubernetes infrastructure. EKS, which is the Elastic Kubernetes service that Amazon offers. IAM, that's like security and permissions and stuff. You have to write a lot of that. Lambda, SREs are really obsessed with building things that have no maintenance. And so one of the ways to not maintain anything is to do serverless infrastructure, right? And that's like such a crappy buzzword, because like all Amazon is, and all AWS is like a bunch of computers with some crazy firewall rules, right? That's all Amazon like web services actually is. It's like a bunch of computers with some applications that they've made for you to like simplify a router or whatever, and just like absolutely insane firewalls everywhere, right? So like Lambda, like yeah, it's still code running on like a server somewhere. So serverless doesn't really make sense. But like what that means is like you guys have used Lambda functions before, right? In AWS, right? So like these days when I build an application now, like let's say I build a workflow where I need to, like my CI pipeline, right, will come out and it will run like a flow where I want to like resize an RDS database, right? Instead of writing like some server with an endpoint, like an API endpoint to like capture like how big, like what endpoint you want to like resize, and, like how big to make it, right? Well, instead do is write that as a Lambda that's part of like a step function flow, right? So that we can just pass that data around through the step function and just do it all through API gateway instead. So getting more and more contact with Lambda, API gateway, and step functions. S3, obviously you'll use a lot of S3. Things are still in S3, you have to touch that. SNS, that's how applications talk to each other very frequently, right? Things are in a queue, they're in an SNS topic, whatever. SQS as well. RDS, that's the relational database storage. You also use DynamoDB, less so because everyone likes MySQL, and so they run RDS. KMS, that's the key management store. There's also like Secret Manager and like a couple other of these versions of this that Amazon offers. You will use all of them for like random things because one engineer will be like, oh, I keep all my stuff in KMS. Another engineer will be like, oh, I keep everything in Secrets Manager. And they're like functionally the same thing and should just be merged into one product or whatever. Route 53, that's the DNS provider, API gateway, step functions, CloudWatch for like alerting and monitoring. Most people use not CloudWatch, they use some external product like Datadog or something other than CloudWatch, because CloudWatch is like actually insanely expensive compared to the competitors. WAF, like AWS WAF. But again, like some companies will use like an external WAF provider, think like Aqua, right? Or like Cloudflare. But then they'll also use Amazon's internal WAF and they'll do them for different things, right? So that exists. You'll do work with security groups, yeah. What is WAF? WAF is the outermost firewall of your whole cloud provider. So if you think about like, you have a VPC, right, it's virtual private cloud. Inside your VPC, you have like a bunch of subnets, and all your infrastructure is on those different subnets. Maybe you have a really simple application, and you just have like one subnet with like all your infrastructure on that, right? When traffic comes from the internet, it passes through AWS WAF, and you could have no WAF rule set up, and it'll just allow all traffic to come in for you onto your VPC, and allow all outbound traffic. But then you can start restricting inbound traffic on the WAF to say like, oh, we don't actually want to let like people from countries that the US has extradition, like not like has sanctions with, like to be able to log into our application because we don't want to have to deal with like returning something to them, or like we only ship to the US, so we don't want customers from outside the US to even touch our application, right? Or we're only available in whatever state. So we can like geo-lock people. The WAF also has like anti-botting kind of built into it. It has some like DDoS protections built in. Right? So you can use like switches you can enable and disable, and it allows traffic into your VPCs. Does that make sense?
Yeah.
Yeah.
Does the WAF detect if someone's using VPN connection?
So it can't necessarily, well, yes and no. You can, no one can detect truly that you're using a VPN, but so like if I was running a VPN like from like NordVPN or some like crappy YouTube VPN provider, right? If I was using their VPN, their IP like range, like their CIDR endpoints are very well documented, right? Like we know that they're buying server infrastructure in whatever colo in whatever data center somewhere, and we know what all those IP ranges are that you'll get as an output. So we can detect if you're using like a VPN that way, but a VPN looks like normal traffic otherwise, right? However, you can allow VPN tunnels into a VPC. So you can actually like VPC peer, which is to say that you can add like an IP range to a subnet in a VPC, and that subnet will actually just link to a different subnet in another VPC, and it will be like that way the two VPCs are effectively connected and they're sharing network space, but there's actually just like a tunnel between them, like a VPN there, right? But if you're hosting like a private VPN at your house and you're connected to like from your phone at school to your like Raspberry Pi VPN at home, like no one can detect like that's VPN traffic. It looks exactly the same as normal internet traffic to the outside world, right? Because it's still normal internet traffic. Like that computer is still just sending traffic over that network instead of your network, right? Does that make sense?
Pretty much how most VPN detectors work is they say, hey, are you trying to ping my service from some server somewhere and in a data center?
Right, exactly.
Like, they can detect that.
Yeah, because the IP ranges that data centers use are known, right? So we can ask because when you go out and buy when you connect to the internet, you get an IP address assigned by Comcast or whatever, right? Comcast had to ask ICANN, which is ICANN, for a range of IP addresses it's allowed to use, like IPv4s or whatever. So the who owns what IP is public information. You can just ask ICANN for that. Mm-hmm. So we know all the data center IP address, right? So yeah, this is kind of the list of things S3's touch. I wanted to briefly, I have time, so I wanted to kind of talk about how an SRE might approach deploying an application, right? So this is a pretty common interview question if you're ever interviewing to be an SRE. So I'll pose it to you as that way. We have a scenario here. You have just been hired as an SRE at company A. They are brand new. They have some crappy iPhone app that's going to connect to a backend that they have made via an API. So the front end is some crappy Swift app they've made, and it's going to connect to your API endpoint. Their backend code has the following requirements. There is a backend with a server that can support 50 users. There's a database that supports 8 connections. There are no constraints on budget. We can spend as much money as we want to deploy this application. And the marketing department believes that we are going to have no more than 200 concurrent users at any given time, right? That's how much user interest we have, right? So let's figure out 2 ways to deploy this application, right? That would meet the customer requirements here. There are way more than 2 ways, right? I can already think of 6 ways that we can deploy an application like this, right? So let's think of 2 kind of together as a group, right? So who wants to hedge a guess on the first thing we need? If you were thinking of an AWS service that you would need to host this application, yeah?
Or RDS or something.
We probably need RDS for the database, right? Yeah. Probably a SQL database or DynamoDB, but we need some database, right?
Yeah.
Yep.
Run the web server on EC2.
Yeah, we can run the web server on EC2. That's absolutely a great solution. How do we make those 2 things talk to each other? What do we need internally? Anything?
VPC.
Yep, they need to be on a VPC, and that VPC needs to have...
Load balancer.
Well, not necessarily. We don't need a load balancer necessarily, but we need security groups, right?
IAM.
So that we need, security groups are not IAM,
Okay.
but security groups are how EC2 can talk to things. We do need IAM roles to be able to create crap in AWS. Yeah.
On the backend web server, could you use Amplify?
Can we use what?
Amplify.
Amplify would not be a great use for the backend. Amplify is great to host friends.
Oh.
Yeah. Yeah, so we have like a backend host in EC2 that connects to an RDS database or DynamoDB, right? And there's like security groups there. There's inside of VPC with like subnets all built, and there's some iron rules to talk to that whole thing. What's another way that you could deploy that application? Yeah.
Was that saving anything on the EC2 instance, or do you need block storage or anything?
No, we don't need block storage probably, but that's a great clarifying question. And so like another note for you, just like for general interview prep, when you start, when they pose you a problem like this, instead of diving in, the first thing you should do is ask like 3 clarifying questions at a minimum, and like try to build out like what do we actually need. Like there are no constraints on budget, but are there constraints on services we can use? Right? Are there constraints like, oh, how is their application written? Like, are they comfortable rewriting their application if necessary? Like those kind of questions can help prompt like paths we can't go down. So your hand first, then.
Yeah, so it says this backend web server can support 50 users. Does that mean one instance?
One instance can support 50
that
users.
to do more.
Yep. So what would we? So we could either how would we be able to duplicate that? What are some ways to do that?
Yeah, auto scaling.
We can auto scale, like put all these things in like in a load balancer, right?
Yeah.
We could also just make 4 EC2 instances
Yeah.
and just build them and not even worry about scaling technically,
Yeah,
right?
that's true.
Yeah, that's what I was going to ask. So since you mentioned earlier how SREs typically think in terms of scale, would it be more appropriate to think of scale in this situation, or
Yeah, absolutely. We should be planning to scale this.
planning to scale? Okay.
Yeah,
Only up to 200, or should we technically think of unlimited?
that's a great question. I think like for now we should plan for 200. That's what the marketing department says.
Right.
But like because we have no budget constraints, we could just plan for like unlimited users, right? And make this thing huge, right? When we scale, do we want to horizontally scale or vertically scale? Horizontally scale, right? How do we horizontally scale our database?
Well, with the RDS, it's pretty hard, but if you use DynamoDB, we scale really easily.
It's really easy, right? But if we use RDS, it's more challenging to horizontally scale. Do you know how to do it though? If you knew, like, do you know off the top of your head?
Like sharding?
That's one way to do it.
Read replicas.
Read replicas is the other way, and that's the way Amazon says it's cheaper. Is to do. Well, that's the way Amazon recommends, which means it's actually probably not cheaper, but but they recommend doing read replicas, right? Okay, great. So things have gone really, really well. Our app went viral on Reddit. Oh, actually, we needed to think of another way to host this thing. Sorry, I messed this up. We needed to think of another way to host this thing. So we have an EC2 instance model.
Can you containerize the web server, or can you just do that?
We can containerize it and then post it where?
Probably onto like app runner or
Runner, EKS.
We could Kubernetesify it, right?
CS.
ECS too, we could run it in ECS, right? So you see there are a lot of different ways to host the service, right? There's not just like the first way of EC2, right? We can make things hosted in other ways. What are the benefits of hosting something in EC2 over EKS? I mean, off the top of our heads. What's the benefit of hosting something in EC2?
Less complicated to manage.
So it's complicated to manage how?
I don't know. I have no experience in EKS, so I can't really say.
That's fair.
But
So
I just heard it. That's the thing.
that is true. That is true. So it's less complicated. Like when we make things in EC2, like all we have to do is like make a server, and we can just like run some crap. Like Amazon will auto run some crappy deploy script for us there, where we can like set up our application. You know, like go pull the source code of our application, or we can even just give it an image, right? Like we can create like an Amazon like machine image and just spawn our EC2 instances with that image, right? So it's a lot easier to like manage in that way. With Kubernetes, we probably want to do things as like Helm charts. So Helm is a piece of software where we can write a bunch of YAML, and it will like configure our pods for us and tell Kubernetes like how we want our pods deployed and how they need to scale and that sort of thing, right? But Kubernetes takes care of the scaling for us too automatically, right? So that's one of the benefits of K8s, right? Is like we don't have to run a load balancer or pay for a load balancer. Kubernetes does that, right? We just tell it like, hey, this pod or replica can hold like this many users. So if you see more than this many connections, like we need to spin another one and move them there, right? Versus like the load balancer. And then the same thing is true either of like having a health endpoint supported in both cases, right? We can absolutely just containerize this thing. Can we run a container in a Lambda?
Yeah.
And put like API gateway in front of it? No reason not to, right? And if you really wanted to get fancy, you could put like Redis in front of all that too, right? And cache all your API responses. So like the thing is like super fast for scrolling their Instagram page or whatever the crappy app does. All right, so our app went viral on Reddit, and now the infrastructure we created can't support 200 users anymore. Like we have like thousands of users now, right? So how do we scale the infrastructure in either method, right? We talked about how to do it in Kubernetes that does it automatically, right? And we talked about like load balancers. What metrics we want to collect for load balancers to decide when to scale?
Like percentage utilization of CPU, maybe memory.
Yep, CPU, memory, how hot the server is getting, maybe bandwidth too,
Yeah.
right? What's another way we could scale? Like another trigger we could scale on? Number of users connected, right? We could just track the number of connections, right? When can we not scale? Right? When's a case where we can't auto scale this server? Can we think of one?
When our backend is completely overloaded.
When our backend is so overloaded that it can't even shed users, that's a great example. Like the scale won't fix that problem, right? Like if we like scaling up, like we're not going to be able to scale fast enough to solve that, right? So like if our user graph, like I'm going to draw this with a laser, right? Like we have a pretty steady user increase, and then all of our users go away, and then suddenly it does that, right? That's what happens to Reddit every single day. At like 5 p.m. Eastern, Reddit just like dies because like the number of users they had all day was like very steady of all the people slacking off at work, and suddenly everyone's off work and checking their phone, and their number of users like more than 10x's in 30 seconds at 5 p.m. Eastern, right? What do you even do about that? Like when I was at DraftKings, right, we had what we called the Gronk spike, where in 2017 in particular, right, the Pats were in the Super Bowl, and everyone, you know, it's a regular gaming product. At the time, it was mostly daily fantasy. So people are playing fantasy sports, right? They're playing fantasy for the Super Bowl, and Gronk gets a touchdown, and he takes the football and just like spikes it to the ground, right, to like celebrate his touchdown. And then the Super Bowl goes to commercial break. So every single person in the entire fucking country that uses DraftKings takes out their phone and checks how many fantasy points they have at once, all simultaneously, right? So we had like a steady increase of users because like users have an advantage in their fantasy lives because like fantasy is a game of information, right? You have as much information as you can the moment before kickoff. So users would, power users would build their lineups right before we launched the building at kickoff, right? And then everyone would close the app and watch the game until the first commercial break, which was usually a touchdown, and they'd all open their app at the same time, and our user traffic would go from, you know, the nice slope all day to the lowest it has been in a 6-week window, right? Where no one's looking at this thing, to 400x our peak during the day. Like, what do you even, like, you can't scale fast enough, right? Like, servers can't provision in 15 seconds. What do we do?
I think you mentioned this before, but maybe pre-scale?
Yeah, we pre-scale, right? Like, we have to work with the marketing department and be like, hey, like, how many users do we think we're going to get to the Super Bowl this year? And then there's some art of taking the marketing number and multiplying it by your fudge factor. Because basically what happened to DK in 2017 is the app crashed for like an hour, right? No one could log in to DraftKings for like an hour because like all the infrastructure just died, right? They had to like restart, like everything was just so like, it's got so many users that like user connections like weren't even processing anymore. The CPUs were at such high util that like they just got stuck in this like dead, like over-threaded state, right? So like nothing is accessible anymore for like a long period of time. And think about the amount of lost revenue from that like window, right? When you think about like how much like a company like Amazon makes per second, right? Like I think DraftKings was like estimated at like, I think in revenue it was like $250,000, $300,000 a second on like a normal business day. So if the app was down for like 10 minutes, like how many hundreds of thousands of dollars did you just lose the company? Technically, like a lot. Yeah.
So football games or any games can be unpredictable. So how do you pre-scale something like that?
Yeah, exactly. So you work with marketing, you gotta figure out like, hey, how many users do we expect to have? And marketing has like a pretty good understanding of how many users we're getting. Because like, first of all, they like, we're, like DraftKings is a company that runs Super Bowl ads, right? So like, they already know like what exact time during the game the Super Bowl ad will be on. And the NFL tells them how many people are going to watch the Super Bowl. And we know from like our marketing factors, like X number of eyeballs equals certain percentage of people trying out DraftKings for the first time. And also X percentage of eyeballs equals already existing DraftKings users logging in. Right? And so the marketing team has like a conversion there already. And so you would get that number from them, and then you would multiply that by like whatever number made your boss happy, basically, to basically kind of guess, like over-guess, right? Because it's way cheaper as a company to over-provision and spend an extra like 100K on Amazon for like 6 hours than it is to lose 100K in 1 second, right? Like, pretty easy value proposition there, right? Like spending 100K for 6 hours versus losing 100K per second. So you just overscale like to absolute hell, right? Like we just like overscale like crazy every single year, right?
I guess Netflix should have gotten the memo during the last.
Yep, exactly the same problem. Right? They just did not expect so many people, right? Like I was illegally streaming that fight, and I watched the person I was illegally streaming. I don't have a Netflix subscription anymore. I canceled mine, but I was watching the person who I was streaming the fight like click through a Netflix UI on the screen share that they had shared out. I was like, oh god, things are going bad. Like, you know? So yeah, exactly. Like we have to pre-scale because like we can't deal with this traffic. For things that like have reliable patterns, we can easily pre-scale. Like we don't have to pre-scale for it, right? Like there are some things like, you know, like as people wake up on the East Coast, we see more users, and as they wake up, as the sun moves across the country and more people wake up, like we expect to see more users, and so we can like nice gently scale for that, right? But sometimes we just can't, and we just have to pre-scale. So yeah, we kind of entered the figuring out some stories and rambling. I'm happy to talk about like on-call a little bit more here. I think people are happy to hear that. Yeah.
Yeah. So 5 years into the industry and you don't have a degree, is that a problem?
Nope. Yeah, I think the hardest job I got was my first one. So I mean, my career I was very fortunate. So like a little bit of backstory of like my career. I was at UML from 2017 to 2020. I was not a very good student. I will say that pretty frankly. I did not do super great in school. I kind of skated by in a lot of my classes. I spent a lot more time across the street on North Campus than I did on this side of the street North Campus. If you know what I'm saying. So I was not a great student, and then COVID happened, right? And I was like not doing super awesome in my classes, and then COVID happened. And I was like, oh sweet, I just get to pull the eject button and get like free grades for all these classes. And so I passed that semester. And then the fall happened, and like online school sucked. Like I did the fall, and online school was like terrible. And I was like doing worse than I was in online school than I was in normal school, right? And during that time, the summer of COVID, I got an internship at a little company. And I stayed on for the fall semester and worked my internship. And then over Christmas break, I was like, man, I do not want to go back to school. Like I'm at least gonna take a semester off, I think. And I asked my manager, like, hey, do you think I could have, like, could I go full time for like a semester? Like, is that something that we could do? Like, I'm part time right now, but you guys have like, you love having me. Like, could I go full time? And my manager was like, absolutely. We have the budget. We were actually going to offer to see if you want to go full time this summer, at least for the summer. So here, let me like throw you together an offer letter and get approved from HR, and we'll see where it goes. So next day, my manager sends me an offer letter, and I did not, just some extra background, I did not grow up like super rich. And so my manager sent me an offer letter that was more than my mom and dad's combined income for just me, which was like $85K a year. And I was like, absolutely, I'm gonna do that. And I just didn't enroll in classes again. So I actually never officially withdrew at the university. I got an email like, I think 6 months ago, and they officially withdrew me. Like finally. Like I just got that email, and like now I'm getting the emails like, come back, like you can finish your education. No, I'm good. I'm good. At school I did not get along. If I was ever gonna do anything, I would do like an associate's degree. Just to have like some formal education. But the first job is the hardest one. And then that job went to shit. That little company like went to absolute crap. And I started looking for a new job, and my whole team was also quitting. Like all the SREs in this company decided like collectively to quit. and get new jobs. And so I got my job at DraftKings. And so my coworker Steve announced to the team that he was leaving on Wednesday. And then so he gave us 2 weeks notice, which was like 2 weeks later, it's Wednesday. And on that Wednesday, I gave my 2 weeks notice on Steve's last day. And then on my last day, my coworker Chris gave his 2 weeks notice. Chris's last day, my manager gave his 2 weeks notice. So like the whole team just quit. Like, in like a 6-week, 8-week window, we were all gone, right? And then I started DraftKings, and then I moved to Aqua, and now I'm starting a new gig. I signed an offer letter today, but I'm not gonna disclose where I'm going yet. It's not public. I don't want to say where I'm going until it is public, and I am working there. So I'm going to be a senior engineer now. It's like 5 years in. I don't think a degree is like a blocker to me as a site reliability engineer specifically. I think the most important thing when getting a job post-grad is internships. I don't think degrees matter even a little bit if you have internship experience, right? When I was at DraftKings, I was doing job interviews there. I did job interviews at Aqua as well. I imagine I'll do job interviews. We threw away every single new grad application that did not have an internship on it. Like if your resume did not have an internship and you applied for a new grad, like we didn't read your resume, quite frankly. It didn't even make it to the interviews. Like the manager or HR people threw away, right? So like internships and co-ops are the #1 contributing factor to like getting hired post-grad IMO. And the other thing about that is like if you can't get a co-op officially, like you don't want to like co-op center won't work with you don't have an INFGPA, just take a semester off and get a co-op on your own. Like if you just take the fall semester off and work summer through like fall on like an unofficial, not sponsored with a school co-op, like the company doesn't care when it's not sponsored with a school. Like companies will just let you apply anyways. You just do all the work for the co-op program anyways. You just take a semester off. None of your financial, this is not financial advice, so don't come at me for this if this doesn't go for well for you. But your loans won't be serviceable. Like the feds won't come asking for your student loans. If they do, you can ask politely for an extension to be deferred, and they will grant it to you. Right? So like none of your loans will be due. Like you just won't be in school for 1 semester. You don't have to withdraw from the university. Like the university will tell you that you have to withdraw if you don't want to do that. Just don't enroll. If you just don't enroll, they won't even bill you. Like you don't have to withdraw. They'll tell you to withdraw. You don't have to. Like that's not true. Like if you just don't enroll for 1 semester, just do your own co-op. Like yeah, you won't get credit for college credit for the co-op. Oh no, you have to take oral and written communication. Like it's gonna be okay. All right, like we're gonna make it, guys. Like yeah, like I think the #1 contributing factor to success post college is internships and co-ops. Yeah. I saw you raise your hand again halfway through.
Oh no, it's you said you're gonna tell us why it's a bad idea to not pursue.
It's probably, and especially if you are like already in your junior year, like some cost wise, like economics of that, like just finish it at that point, like just finish it. Like if you are a freshman, also like it's easier to get, even if you're not a freshman, it's easier to get the internships that you're going to need to get a job if you don't have a degree, if you are working on a degree, because it's much harder to get internships if you're not working on a degree, right? Like that's the first differentiator. So like you at least need to be like in college probably to get a CS internship. Although like at DraftKings, like we for SREs hired people straight out of coding boot camps and they were making over $100,000 a year. Like right out of this SRE boot camp that we like to hire from, and they were making $100,000 a year like straight out of boot camp. Our college grads in SRE were making $140,000, but out of boot camp we were making $100,000, which is still really not bad. like $100,000 a year is like that is a pretty good salary for no college degree, right? Like, SRE is a high-paying role, and as long as there is infrastructure, there will be SREs. So it's like a pretty economically resistant role as well. Yeah.
You talked about this a little bit earlier. How do you manage, like the work-life balance aspect of a job like an SRE?
Yeah, of course. The most important part of work-life balance is understanding that we work to live, not live to work, right? If you live to work, that's great for you. I don't, right? Like, I like having hobbies. I like doing things outside of work. And so like managing work-life balance is really challenging. It can be really challenging, especially during your on-call weeks. The most important thing for work-life balance as an SRE is like being able to, when you're not on call, separating your work from your rest of your life. And for some people it means going into the office is really helpful. For some people it means having like a dedicated office space at home. You will have a company laptop. Like, don't do personal stuff on a company laptop. Don't do work stuff on your home machine, right? Like, try to, like, for me at least, separating my lives from my work life and my home life really helps with my work-life balance. And then when you are not on call, like, if your company uses Slack or Microsoft Teams or whatever, like, there are great notification settings in there that you can tune and just turn everything off. Don't respond to messages after 5 p.m. Right? Why? There's an on-call engineer for that. Let the on-call engineer do all that. If they need help, they'll escalate the page, and you'll get paged. If you're on the escalation tree. There's no reason for you to check Slack at 11 p.m. if you're not working. Right? Like, don't. Right? Like, and if you're an SRE and, like, you're on call, you also don't need to check on Slack at 11 p.m. If something is important, they'll page you. Like, if it's not important enough for them to page you, then you're not expected to respond to it. And if that is not true in your role, then that's a discussion with your manager about on-call expectations and work-life balance expectations, right? And if that's something that your manager is not willing to do, like, it's time to look for a different company, right? Because it's just not worth giving up your whole life to make, like, 240 TC or whatever it is that you're getting, right? Like, it's just not worth it, right? The reason you're making 240 TC is so that you can enjoy your life, right? Not so that you can be a slave to your MacBook, right? So, like, managing, like, work-life expectations, especially in SRE, around on-call is a lot of just, like, don't open your phone, right? Don't respond to that Slack message after the work hours. Like, set the boundaries right when you start. That, like, you have work-life expectation boundaries and you will keep them. And people usually won't care. It's usually not a big deal. If it is a big deal, like, and you're at Amazon or something and it's like a huge disaster for you, like, sure, whatever, right? That's, like, I guess what you agreed to. But yeah, for, like, from, like, how, like, to handle work-life balance, it's really just a focus of, like, turning off your phone and only being available when you have to be available. And then also, like, the stuff you do at work is not probably going to be stuff you do at home high frequency, which really helps. Like, even though, like, I know, like, as programmers, a lot of our hobbies are also programming. Like, we probably do programming work. Sometimes, like, you'll build something at home. Like, I have a small home lab system that I operate. Right, I operate a couple servers at home. Right. Those are, like, different skill sets than SRE because, like, my home lab is not provisioned like AWS, and so I don't really run it like a site reliability engineer. Right. So part of that too is, like, just keeping what you do at work and what you do at home separate really helps. Like, making some time to make sure, like, if you work from home, like, I leave the house I leave the house every single day. If I stay at home, if I don't go outside once a day, like, when I'm working from home, I will go absolutely crazy, right? So, like, just figuring out what works for you and, like, managing your work-life balance is really a huge part of it. But then, like, I mean, we talk about, like, all the things in the day of life, right? Like, almost all this stuff doesn't require you to be available outside of work. Like, none of this requires outside of work. Yeah. It's only this. And so just, like, if your on-call rotation is super brutal, like, there's only, like, 3 of you and you're on call, then maybe it's time to have your a conversation with your manager about, like, how can we make on-call better? How can we reduce the number of pages we're getting, right? And changing, like, definitely, like, noisy pages, like, is probably the most annoying thing. Of, like, you're monitoring everything, which is great, but you're alerting on everything. And it's, like, something that fixes itself. By the time it's fixed itself, it's already paid you, right? Like, that's not helpful, right? Like, so working with your manager to kind of solve those problems is a huge part of that too.
A little bit of a follow-up to that.
Yeah.
Since you've worked this similar role at multiple companies, how much would you say is, how much of the problem of work-life balance is from the role of an SRE versus the role at a particular company, like company culture, etc.?
I think it's all company culture based,
okay, rather
than the role based. That being said, like, companies have different definitions of what SREs should be for them. And so that is how it's different. Like, the overarching role does not require beyond, like, on-call availability, like any issues with work-life balance. Okay. But if the company is going to be like, hey, you have to get all your tickets done this week no matter what, and you're going to have to work a 60-hour week, like, that sucks, right? Like, that's just the reality of, like, your manager and your team and your company, and not the reality of being an SRE. Okay. Yeah. Thank you. Yeah, of course.
Yeah. I want to ask a question. How many times, like, when you were on call, would you get paged at, like, I don't know, 3 a.m. or something like that? How much of an inconvenience?
Some weeks, never. Other weeks, 6 times a night. All week. It really just depends on, like, if you prayed to the server gods and its stuff is working this week. Like, I don't know what to tell you. Like, it really just depends on like the applications you're supporting and the infrastructure you support and like how it goes. There are sometimes where pages are caused by human error. Sometimes pages are like an irrecoverable disaster that take forever to be on. I think my favorite page I have ever gotten was we had a bunch of Kubernetes test infrastructure. We had like one prod environment and like 8 test environments, and we got a notification that one of the test environments was down. And it's a P1, so we logged on like online. It's my first night ever in my college year, but first night ever. And I log in, wow, this pod is down. This whole cluster is down. Like, gee, I wonder what's happened to it. And then the next cluster alphabetically went down. And then the next cluster alphabetically went down. I was like, what is happening? I'm watching our clusters march towards the production cluster, all turning off, and it stopped right before the production cluster, and it all came back. And so we couldn't figure out what happened. Like, didn't make any sense. Like, it was just some like Terraform logs. Something must have triggered a Terraform job. We put it in the incident report, and we're like, we'll deal with it in the morning and figure it out. But like for now, we're going back to bed. Turns out one of my coworkers had just had a baby, and the baby woke up in the middle of the night, and he decided to get some work done, and upgraded all the Kubernetes clusters that were not the prime environment. So that'll turn off, and you just forgot to turn off the alarm. You know, happens. Like, right? And other nights, like, you know, you just didn't ever get paid much, right? It just really was. It just depended on the week. Sometimes it was really noisy. Like once, I think the worst night I ever had is I got woken up at 2 in the morning. It took me 35 minutes to resolve the page. I went to bed. 10 minutes later, something else woke me up. It took me 2 hours to resolve the page, and I got woken up an hour later again. And so I just, like, at that point, I just didn't go back to sleep. It was like 5 in the morning, and like, fuck it, my day is starting now, I guess. Like, time to make breakfast. like I have cats, and the cats were like, oh, you're awake, which means I'm awake for the day. Like, they're not going to let me go back to bed, right? So that's my morning now, right? And I think that was the worst of it. But also, like, when that happens, typically companies, managers especially, who have been site reliability engineers before, so like S3 managers are frequently former S3s, typically have a pretty good understanding of the fact that like you were just up all night and just give you the day off. It's like a courtesy day of like, hey, you just worked like an 8-hour shift overnight, just don't work today, right? At DK, when we were on call, the expectation, like, there was no expectation we got any sprint work done on the days we were on call. Like, it was the hope that you would get sprint work done, but like if you didn't because you were busy on call, like, okay, fine, whatever, right? Obviously, like if you weren't busy on call, you didn't get any work done, like that would be a problem. But like if it was a busy on call, like, there was no expectation you got any work done on those days.
So it all just really comes down to your managers and how they kind of treat the.
Yeah, managers, company culture, and like the application you support. And sometimes the application you support is just poorly tuned, and it's on you to advocate for you to tune it better.
So yeah, I was gonna ask that too. Like, so can you like foresee these problems happening at all? Like when you're doing
Oh yeah.
day and just,
Oh
like,
yeah.
kind of mitigate it before it gets out of hand.
Yeah, absolutely. A lot of servers like throw 500s when they don't need to, and we alert the number of 500s. And so like in the first week something is up, right? Like you just monitor it really, really closely and try to define its behaviors for that first week, and then you tune your alarm based on that. So things are usually noisy right when they come online, and then you tune the alarms so that it's not noisy anymore. Yeah. Any other, yeah?
Can you talk more about what you mean by owning? Like,
Yeah.
service owning?
Yeah, for sure. So like ownership is like we've been talking about like getting paid for something when something goes offline, like being responsible for fixing it, right? Ownership is also like if the thing in production breaks other stuff, like you're responsible for that. If the thing in production has like some upgrades that need to happen to it, then you need to like figure out how to make those happen without breaking other stuff. Ownership is also like tagging things and making sure that like things are compliant with our other rules, right? So like Aqua had some really strict rules on all infrastructure had to be tagged with who owned it and who was like basically responsible for it if it ever misbehaved or went down or something. And if infrastructure wasn't tagged and it was in infrastructure for more than like for 3 days or more if it wasn't tagged correctly. So we had a process that would come around a job every couple of hours and would try to find the owner of that thing, and if it could find the owner, it would tell the owners like, hey, you didn't tag this correctly in Slack, or just message them. And if it couldn't find the owners of that thing, it would just, after 3 days of it being there and it being tagged incorrectly, it would just delete it. Like it would just destroy the infrastructure. And we had a rule that like you could not blame the fault of a production incident if infrastructure was deleted because of the bot, right? If infrastructure was deleted because of this process, it was not the reason for your production outage, right? Like the reason for your production outage was that your infrastructure was not tagged, not that this bot destroyed your infrastructure. But ownership just kind of comes down to like who's responsible for when things go wrong, and also who's responsible for like maintaining and upgrading in the future, right? Because if like whatever development team that made whatever product gets laid off in like 3 years, and we need to like destroy it, we can't simply say that's not my job, right? Like it is our job. We own it now, right? That team got laid off by a business decision, and now like we own that thing, right? So it's our responsibility to maintain it and make sure it gets destroyed correctly. And when we destroy it, we make sure it's not a dependency for other things. If it is, we fix it, right? Does that answer that question?
Yeah, yeah. Like we've had people come in and talk about like project management, and that's like a different definition. Like you have like a product owner. So I was kind of confused when you first said that.
Yeah.
Between like a product owner who is like maybe the Scrum Master or something like that versus
Yeah.
what you're talking about.
Yeah, SREs do, like there are product owners like in SRE like hierarchy, like we have TPMs and stuff, right? And there's like, there's stakeholders and that's all managed. I don't know what those people do. Honestly, I have no idea what a TPM does every day. I couldn't tell you what those people do. I have no clue. Like, I don't know how they helped change my job at all. I never saw any Jira tickets written by them. I don't know. Like, I think they made epics. I don't know. Yeah, yeah, there are like that definition of owner too that does exist, but like SREs are less responsible for that.
The owner is just really who's taking blame for when stuff goes down.
Yeah, not quite blame, but like responsibility.
Yeah.
Right? Not blame. It's never like, oh, it's this person's fault or it's SRE's fault. But hey, this is the problem that happened and now it's SRE's responsibility to fix that problem and stop it from happening again. Yeah.
So it's, who do you message when the thing breaks? Hey, it's more than, and whose fault is it for breaking it when you're talking about ownership?
Yeah, less whose fault is it for breaking it and more who do we message when it breaks. Right? Like we can always figure out why something broke after like, we don't, like when the house is on fire, we don't figure out how the fire started. We put out the fire, right? And then we try to figure out how the fire started, right? So in SRE, like when something breaks, like we don't try to figure out and point fingers at how it broke. We stop it from being broken. And then we can go back and do like a report on why it broke, right? Like an incident report or a summary or whatever you want to call it. Yeah. So I think you gave me, I think I had budgeted until 8. I think I'm right on time. Are there any other questions or anything to go over? I know you guys have like some activities you're doing after, right? Cool.
Do you have any more regulation stories?
Oh God, you want to hear regular stories?
Actually, what we could do is we could break for pizza, then you can talk while we have pizza.
Yeah, that's a great idea. Sounds good.
Alright.
Awesome.
It's on the other side. Just
No, the mouse is here.
Yeah, but
Oh,
drag
oh.
it through.
I'm looking. Okay, I